Hello and welcome to this talk about our paper titled Automated Large-Scale Analysis of Cookie Notice Compliance. So every day while browsing the web, we're constantly interrupted with frustrating cookie notices like these. And we keep seeing these cookie notices because most websites track us and privacy regulations have been introduced to regulate this. So in the EU, we have the General Data Protection Regulation, the GDPR, and the e-privacy directive. The e-privacy directive requires consent for non-essential cookies. And the GDPR defines this consent. It should be freely given, unambiguous, and it should be specific for explicitly listed data collection purposes. Let's have a look at this typical example of a cookie notice. So here, we don't have an option to opt out. So consent is not freely given. It's not clear what would happen if we ignore the got it button and continue to browse the website. So consent is ambiguous. And the cookie notice says that the cookies are used to improve the user experience, which could mean a lot of things. And so the data collection purposes are not explicitly listed. And a significant novelty of the GDPR are the fines that can be imposed and which can go up to 4% of the company's global annual turnover. And we have seen several large fines indicating websites' non-compliance. For example, Google and Meta were fined 150 million euros and 60 million euros respectively for making it harder for users to reject cookies than to accept cookies. And as a result of this, they have quickly updated their cookie notice to include a reject button, and many websites followed their example. And so multiple prior works have evaluated empirically cookie consent, showing that many websites were non-compliant or use dark patterns which nudge users towards performing actions that are against their preferences. However, these studies were either manual or were limited to websites implementing certain consent providers. These studies then have the disadvantage of covering only a small portion of the websites that they initially consider. So for example, the work by Bollinger et al. Only covers 0.6% of the websites that they originally considered for their study. And so this could cause a selection bias, as we show in our paper. And most of these studies were also limited to analyzing the first layer of the cookie notice and did not explore subsequent layers. So in our paper, we train and employ several machine learning models which allow us to analyze cookie notice consent regardless of how the website is implemented. Our crawler interacts with cookie notices to uncover potentially hidden options. It determines which cookies are declared by the website and contrasts them with the cookies that the website actually uses. We report on 6 types of violations and 2 types of dark patterns in a crawl that covers 97,000 websites. We also conduct a bias analysis to show that restricting the analysis to websites implementing certain consent providers can lead to a selection bias. So due to time constraints, I'm only going to present some parts of our method, starting with the classification of interactive elements. And the idea here is that in order to be able to have meaningful interactions with the cookie notice, we would like to be able to classify its interactive elements. And for this, we collect and annotate 2,400 samples with one of these 6 labels and train a BERT model on this data set, which achieves a good performance. Next, we apply the model on the interactive elements of the cookie notice to detect the consent options that it contains, like accept, reject, etc. And we also explore cookie notices via detected settings buttons to uncover potentially hidden options. We then browse the website after clicking on each of the detected consent options to extract the corresponding set of cookies. The next step is to analyze these cookies and determine which ones are susceptible of tracking users. And for this, we build upon the work of Bollinger et al., which was conducted in our group and which introduces a model for cookie classification based on gradient boosting. So it classifies each cookie as one of the 4 labels: essential, functional, analytics, or advertising. And so we retrain this model to predict a binary label indicating whether the website uses cookies for analytics or advertising. And we refer to these cookies as AA cookies. And then we classify a website as using AA cookies if we detect 2 or more such cookies. And this model achieves a precision of almost 99%. And now, given the data from the crawl and from the machine learning models, we follow this decision tree to detect 6 potential violations. We have a similar decision tree for dark patterns. And so, for example, if we detect a cookie notice, and then we find a reject button, and then we find 2 or more AA cookies that are set despite clicking on the reject button, then we report an ignored reject violation. All right, let's have a look at some results. So we considered the top 10,000 websites in 15 European countries according to the Chrome User Experience Report. And this resulted in a list of 97,000 websites. And so, for example, in roughly 1/3 of the websites where we detected AA cookies, there was no cookie notice. And this violates Article 5.3 of the e-privacy directive. In roughly 1/4 of the cookie notices, the data collection purposes were not properly declared. And maybe a bit more shocking is that if you open a website and you didn't even have the chance to interact with the cookie notice, and in roughly 3/4 of the time, you'll have AA cookies that are being set. And if you take your time to interact with the cookie notice and to reject all of the cookies, then in roughly 2/3 of the time, the website would still use such cookies despite you explicitly rejecting them. We also crawled some additional websites from the lower popularity ranks to perform a popularity-based analysis. And we observed a facade of compliance where more popular websites tend to be more compliant with visible requirements like including a cookie notice, including a reject button. However, these websites were more aggressive when it came to data collection, and they were more likely to ignore user choices. And the last type of result I would like to present is an example of the bias analysis that we conducted. So IAB-TCF is a consent framework that standardizes consent management and can be integrated with consent providers. And some prior work restricted their analysis to websites implementing this framework. And what we show is that such restricted analysis leads to results that are significantly different from those over the overall distribution of websites as is shown by this figure. Okay, so our results show that consent is broken. So what's next? A potential step forward is through enforcement. And for this, we started collaboration with the French Data Protection Authority, the CNIL, and the nonprofit organization NOIB, which both have a great track record of enforcing privacy regulations. And to make our methods reliable for enforcement, we had tuned them to have low false positive rates. So this is shown by the manual end-to-end evaluation that we conducted on 500 random websites. And you can see that in general, we have high precision values at the cost of lower recall values. And so in conclusion, we developed a general method for analyzing cookie notice compliance. We've employed our method to analyze 97,000 websites addressing the selection bias of previous studies. And overall, we found that about 3/4 of the websites violate at least one legal requirement. Yeah. Thank you for your attention.